Okay, good morning. Welcome, everyone. In spite of the provocative title of Machine Learning and AI, Arms Race or Opportunity, we're going to spend about the next 50 minutes with what I think is the most accomplished panel here at the conference to talk about the role of machine learning in identity and the future role that that is going to play. My name is Matt Thompson. I'll be moderating the discussion today. I'm with Capital One and lead our identity as a service business. Immediately to my left is Reed Taussig, the CEO of ThreatMetrix, a company he has led since 2008. Prior to ThreatMetrix, Reed was the CEO of Panelists Software, where he led the company from inception to IPO, a serial entrepreneur, a lot of successful growths and exits from companies. So thank you, Reed, for joining us today. To Reed's left, we have Ray Carvalho, CEO of Emailage, a global fraud prevention startup he founded in 2012. Ray is a computer scientist with over 20 years of experience as a CTO. Thanks for joining us, Ray. And then last but certainly not least is Sunil Madhu, CEO of Socure and has spent his career as a security architect. Sunil is also a serial entrepreneur and has several successful transitions through IPO and acquisitions. So we're going to focus our discussion this morning around four primary areas with machine learning. First is going to be a discussion around performance, then robustness. We're going to get into some embedded biases and interpretability challenges, and then end with some market changes in this area. So that's the agenda for today. We're going to spend the last 10 minutes or so taking questions from the audience. But before we start into those areas, I wanted to see by show of hands, how many people know what machine learning means? And keep your hands up if you're involved with machine learning projects or the development of machine learning algorithms at your companies. Okay? So quite a few people are coming in with a baseline, but for those of you that don't have background in artificial intelligence or machine learning, I thought it'd be helpful for us just to baseline on what it is that we're talking about. So machine learning as a subfield of artificial intelligence. So looking at Merriam-Webster, which is always a great place to go for definitions of things, defines artificial intelligence as a branch of computer science focused on the simulation of intelligent behavior. Going back to Arthur Samuel in 1959, who's one of the pioneers in artificial intelligence research, he defined machine learning as a branch of computer science focused on giving computers the ability to learn without being explicitly programmed. And then a more recent definition by Tom Mitchell in his book in 1997 titled Machine Learning provided the definition that it's a computer program that can learn from experience with respect to some class of tasks T and performance measure P if its performance at task in T as measured by P improves with experience E. So with that said, let's turn it over to our distinguished CEOs and panelists to share what their definition of machine learning is and how they're applying it in their companies today. Reed?
Great. Is this thing live? Yes, I guess it is. So, machine learning, AI, is a tool in the tool bag that is useful when trying to arrive at an answer is otherwise difficult. The real issue here is that a lot of people, machine learning, AI is on the top of the hype cycle right now. Personally, I think when computers can actually create a joke that you laugh at, we should all run at that point in time, hide. But really the bigger issue, I think, is data. Machine learning and AI works better if your data is good. And I see a lot of people spend a lot of time and a lot of money and a lot of effort investing in machine learning, but don't really pay attention to the data. And as a result of that, the output is great. So there's a lot of different pieces to this. Deterministic solutions. If I can determine that Matt really is Matt on a deterministic basis, I don't need a probabilistic tool to reiterate that. But the quality of the data, and then really getting a great focus in terms of what am I trying to get out of the machine learning piece. For ThreatMetrix, what we really focus on with machine learning and AI is predicting the future, because a deterministic solution is great for determining the present in many cases, but it doesn't work as well for determining the future, and there it is truly valuable for us.
My turn? So it's a hype word, I think. A lot of companies are saying they're using machine learning, and a lot of them are actually just scratching the surface. We've been working, we're been using machine learning a lot, especially to determine what we need to send to our data sources or not. We've been using machine learning to determine the best score for our algorithm. Machine learning is a powerful tool, but as you say, there's a lot of the main point about machine learning. Algorithms are today open source, so anybody can have access to the algorithms today. TensorFlow, all those places. But the data is the key point. I think providing the data verticalized or segmented, the right data point, having the right training makes the most sense for use of machine learning. So our space is it's crazy about getting being ahead of the game against the fraudsters, right? Or identity in that case. So we gotta make sure we're using the right patterns and all those things. And I think it's a hype still, but it's a one way. There's no way back. AI is everywhere. Machine learning is one of the branches of AI. There's deep learning in other different places, and I think it's really important, very good technology to use.
Thanks, Sunil.
Sure. I don't think machine learning is hype. I'm 47 years old. The first hype cycle around AI happened in the 1980s and 1984. And now we've got a repeat hype cycle around AI. But machine learning is a well-established science, and computational mathematics is an extension of statistics. So it's really a set of tools that allow machines to learn different types of tasks. Now, to Reed's point, there's actually a video of an AI system. I believe it's called Robot Dick. He's been modeled off Philip K. Dick, and he actually did make a joke about the fact that if robots took over the world, human beings don't have to worry because they'll be put in human zoos. Machines are able today to do different types of things. They're just not sentient. There isn't a robot that has to kill people unless it's the Defense Department creating a drone or Tesla creating a car that has to learn how to kill people. Most of us are basically working on what I would call, or what was called in the industry, expert systems in the 80s. And this is kind of the newer iteration on expert systems where machines are able to take the knowledge in a specific domain and operate on a vast quantity of knowledge in a fixed period of time to give you probabilistic and accurate results. While, to defer with Reed again, while there's probability theory and so on, it is a fact, in fact, that the patterns exist in chaos. So, the ability of using these tools to extract the type of information for whatever your goal happens to be is really the challenge. Neural networks, which is where most of the news comes from today, and the advancements in ANNs, artificial neural networks, hogs most of machine learning limelight, but there's an entire side of machine learning around linear modeling that has also seen improvement. I think machine learning is here to stay. It's not hype. It has been used by search engines and stock prediction systems and trading algorithms and a whole bunch of systems that power the planet today. And I think that the systems are getting smarter, and they're able to sort of be experts in a lot more domains than they were in the 80s.
Just to clarify real quick, because I don't think Reed meant it's hype in that it's going away. I think it's
just a word.
Reed, did you want to clarify?
It's on the top of the Gartner hype cycle, right? I mean, there's a company in San Francisco called Forkable. They call me up and they say, we've used AI technology to predict what your employees want for lunch. I go, great. 200 restaurants within walking distance, and all my employees can read the menu. So thank you very much. But I mean, it is.
Well, that's the difference, Reed. That it's AI, right? AI is the hyped up word because that's the outermost circle in the Venn diagram. ML is a subset of AI, and deep learning, etc., is a subset of ML, right? So AI is definitely hyped for sure.
Yeah, I think I agree with that. So I think AI is the one that's the hype today. Everybody.
Yeah, I'm not going to share the company name, but I was doing some technology scan the other day, and I was reviewing a company's description of itself that had advanced artificial intelligence for identity management with optional blockchain was the description that they used. And I was
So
like,
you shortened it to blockchain.
wow, that's really a
So
company
make
that
them
I
up.
want to meet with. So machine learning comes in many forms, but always crucially relies on data and training to perform well. Sunil, going back to you, you've stated that industry false positives for predicting fraud can be as high as 20 to 1. You claim that your solution with Socure can reduce that 30 to 50%. That's still very high. What do you think is required for us to improve our performance in this area?
They're operating on old data, so we can actually reduce false positives now to better than 3 to 1. That is, for every one person you stop for fraud, you're inconveniencing 3 people for the wrong reasons as opposed to 20. And that 20 is the worst we've seen. Usually it's around 8 to 1. What can you do in terms of improving accuracy of the system? There are several things. The core of it is really feature engineering. You can have access to the same data sources as I do, except that I might have created a better way of extracting features from that data source than you have, and therefore my model will outperform yours. Basically, it all starts with data garbage in, garbage out still applies. But extracting features from the data that give you the most sense and correlation, understanding very carefully the difference between correlation and causality, knowing that you can create kind of biases in algorithms and models based on the selection of data. For example, you could make an AI system, machine learning system that's racist without ever having a feature in it called race by just simply sampling data with racial bias and then training that against, for example, a label like fraud. And then the machine will start to associate the zip code with fraud, not knowing that those specific zip codes have racial bias. So, selection of data is important. The features you create from the data are important. And then modeling. Fortunately, in the last, I'd say, 10 years, there have been some awesome products introduced into the market from companies like IASD, H2O, Data Robot, et cetera, that I think have helped data scientists do their jobs better. An average data scientist used to be able to create a model in maybe 2 or 3 weeks of work. Now we can generate hundreds of models per hour automatically. And the machine can actually put these models to compete against each other. And so, you can get better outcomes today through a bit of a good cadence and feature generation, and obviously using the latest tools in modeling.
Reed and Ray, what are your perspectives on how the performance has improved and the reliability of these algorithms?
In our case, the network effect, we work with industries where companies are arch enemies, but they in some way using us there or using other companies like ThreatMetrix, for example, probably these guys. With the network effect, those companies are for the first time collaborating. So data still is the most important thing. I think even more important than machine learning alone. I think no company is only using machine learning. I think it is going to grow. It is going to get better. But the network effect and the collaboration, the industry we're working on, especially in my industry, is fraud. There is no one company doing everything the best. Like there's no one company stopping everything. It's you got to use device ID, IP addresses, email addresses. In our case, we use email address, and we kind of closing a certain door that nobody was actually paying attention to by using email addresses. We were the first one to implement that, and we're working with companies. Some companies that use us directly. Some companies use us through the platforms. So platforms, they have a much more robust systems. They have much more access to data. So we are on their risk engine to help them make the decision. I think still the data is extremely important, and the data points that you select, the data points that you use to make your decision, it is really important. I think the bottom line is the companies are looking for the ROI. So how much money, they still spend much more money in preventing fraud than the fraud itself. So how can they, with simplicity, with a product that's simple, they don't need to complicate or take a long time or to implement, how can they get the goals that they set for saving by using simple systems and simple data?
Reed, I want to build on a point Ray just made about companies being willing to share their data to help their vendors mature and improve their models. How has ThreatMetrix thought about the data ecosystem with its partners? Have you required that they share their data in order to help you mature your models, or what has been your approach to maturing models?
So first of all, let me explain what our model is, and I agree with you on the network effect. ThreatMetrix services 6,000 customers globally. We do 130 million transactions a day, 3.5 billion a month, and that number's growing. And we use 740 separate attributes, up to 740. So email, for example, we have 800 email addresses. We have 4.5 billion devices. We have 1.5 billion identities within the network, all completely tokenized. The whole issue of a contributory data model, in fact, you're absolutely correct. If you want to get the right answer, you need to have a contributory data model. In order to do that, you need to provide a model where the information is completely tokenized and irreversible, or your customers simply won't contribute to it. You know, JP Morgan Chase and Citibank are both customers of mine. They're certainly not interested in trading customer names on it. But what they are interested in doing is understanding not only is this person potentially a fraudster, so all of a sudden I see Matt's email address or his associated with 50 different devices, and it's being used on 5 different continents and 3 different time zones. And you know, he's got 50 credit cards associated with him. Well, I can pretty much deduce without AI or machine learning that he's a fraudster. On the other hand, what most of the big financial institutions are looking for out of these models is not necessarily capturing fraud, but it's identifying good customers so that they don't do the step-ups and challenges, which are both expensive and very inconvenient for customers. You will.
I want to sort of make a point there. So if you look at the PSD2 directive in Europe, the directive actually results in banks sharing customer information. If you do a Venmo transaction today, people are sharing transaction information public. So I don't think it's actually true that tokenization is the only way. There are lots of different ways. It really comes down to the compliance requirements of the customer at the end of the day as to what you can store and how you can store it, Reed.
But sharing data is different than sharing intelligence. I think,
of course.
Yeah, those companies, they have to transact each other. But I think the most important thing is the intelligence that they're sharing between them.
Oh yeah, like
especially indirectly.
Yeah,
like
block lists are used across the industry generally, right? So yeah, that's true.
Reed, did you want to finish your thought?
Yeah, I mean, the reality is, I think, is that whether it's GDPR that's driving data privacy, and PSD2 has a lot of privacy aspects around it as well, in order to get globally contributed information, shared global intelligence, that data has to be non-reversible. You have to be confident as a provider that your information is not going to end up in the hands of your competitor, and likewise, you have to be confident the information is very, very accurate. So I think you're going to see more and more contributory models come up throughout the industry. It makes just a lot of sense. And GDPR and other privacy issues, whether Facebook's driving it or whoever else is driving it, is going to force more and more tokenization into this data. So the construct that you're going to have to use, you're going to have to take it as a point of fact that I don't need to know your name to know who you are, and I don't really want to know your name to know who you are.
I disagree with that too. Sorry. You see, everybody likes to talk about authentication, and tokenization has become a fashionable term to use in authentication, so that it refers to the fact that when your session's initially established after you've validated who you are, you can go across to other service providers and simply pass the authentication session token, which can be revalidated. An example of this is Facebook login or open authentication on the internet or SAML in the enterprise. But that only speaks to half the problem. Every relying party application cares about both authentication and authorization. It is inconceivable for an application to be able to personalize its content to the person that's actually using it by simply knowing that you're authenticated. So every application requires attribute information. So if you hash information, which is what you're referring to in tokenization, that is non-reversible encryption, how are you going to be able to provide attribute data to applications that wish to authorize the user in terms of security as well as personalization of content? Exactly. So, every application requires that, and that is provided for in SAML, Identity Federation Standards, where attributes can be federated through an attribute assertion. It is also supported in OAuth and OpenID. The very first thing that happens when you log in with Facebook or whatever network is a prompt that comes up that says, hey, this website or app needs access to XYZ information. What are you comfortable providing access to? Why does it do that? Because the application needs that information in order to personalize it. So tokenization itself is just this fallacy that everybody likes to push out to the market as this panacea, but it only addresses the fact of authentication, not authorization.
I do think that data attribution is important for certain applications. So, for example, if I look at anonymized, tokenized data, would I be willing to provide you a mortgage for $2 million based on simple data or data that has been fully tokenized so that I don't really know who you are? The answer is no. It needs to be context-based. The truth of the matter is that the long tail, the large number of applications, do not really require data attribution at all. If I can determine through lots of different measures that Reed is really Reed and he has a great track record, sure, why not? I'll take a credit card transaction to book a hotel room in London, for example, or I'm more than happy to sell you a $69 product on the internet. If you look at the number of transactions, or for example, if you're a bank and I simply want to go check my bank balance, great. And now I want to actually change my details page. If I can provide enough information, great, I can do that. But I'm not going to give you a $2 million loan. So there is a continuum here where authentication, risk-based authentication, hits a limit, and then you have to go to true data attribution. I completely agree with that. But it is a continuum, and it should be seamless to the customer.
So let me, before we keep going back and forth
You're going
debating.
to disagree with that? No,
Totally agree.
Just wanted to know.
Yeah, I hope you like the
Let's-
disagreements.
Yeah, no, we encourage it. But look, your companies are on the forefront of helping other companies fight fraud. But how difficult do you think it is for professional criminals to create and embed social information to defeat these ML algorithms? And what are you doing to help prevent that?
So one of the theories we had, which we've proven out statistically now, 5 years ago, we had this theory that it's very easy to steal our identities. It costs about $4 to buy any of our stolen identities because 6 times the US population's data has already been stolen. That's a sobering thought. So it makes it very possible for anybody to commit fraud or pay somebody to commit fraud on their behalf. What's more difficult, we found, is for fraudsters to recreate online and social proof. Recreating graphs at scale is a challenge first off. I'll use an example. Let's say LinkedIn. Most of us who've been in the world for about, say, 20 years of career probably have over 1,000 connections easily on LinkedIn. Those connections took 20 years on average to create. So if I were to steal your identity and create a LinkedIn profile, it would take 5 minutes to do that. But then that profile would look odd. It's an island unto itself. It needs to be connected to other people. So now the fraudster has to go about creating an authentic network around that fake ID, meaning they have to create hundreds or thousands of fake identities just to vouch for that one, each one of which would have to have hundreds to thousands of identities to vouch for that one. And these identities would have to interact with each other in human psychographic patterns over time. So if you look at the scale of that problem, you now change the economics of fraud for the fraudster, because normally they just want to commit fraud as quickly as they can before they're caught and run away with as much money as they can, right? That's the game. So, when you up the ante to say, yep, the stolen data now doesn't matter anymore, the stolen data has to have social proof around it and online proof, like most people in the world today. The internet's 25 years old after all, then you've actually sort of defeated the fraudster in a way. Now, can fraudsters age profiles online? Sure, they could. But having studied that phenomena, what we found is that click farms and others that create, tens of thousands, millions of fake identities often, They tend to monetize those identities by selling the artifacts of them. It's more profitable for them to sell the likes and the follows and the shares and stuff with each identity than to sell the identity itself. And then if you were to examine the identity in itself, you'll find that they have weak cohorts. Most people follow things like homophily, birds of a feather flock together. So your friends are similar to you and so on, and you've probably gone to school with them or etc. These patterns do not exist in the cohorts of fake identities. So the network itself is actually a robust system. To spoof the network is very difficult.
So if you're a fraudster, you want to get a free laptop, you're going to go to those companies that sell laptop, like a Dell, Lenovo, HP, Best Buy, all those guys. So if those companies are using different platforms, there's not a lot of network effect unless you're using companies there across the board, assisting those companies that help those companies prevent fraud, like Certify, Equifax, Experian, Cyber, all those guys. So the network effect there is really important as well. So let's say that the Best Buy is using a Certify and
ThreatMetrix.
Lenovo is using Cyber. So how are you going to stop that guy if he's coming to two different places, to completely two different networks? So that's when connectors like us and ThreatMetrix in that case, they are able to, in some way, of course those guys in our case are going to use a completely different email addresses. So although they're using completely different email addresses, by using machine learning to identify different patterns and correlation to what they're providing, their synthetic ID they're using, we're able to stop the guys. So I think it's still the network effect helping decide to what is bad, what is good is really important.
I think the network effect is good from a collective intelligence perspective, because the goal today, as opposed to fighting this with technology 10 years ago, was 10 years ago the tools that you'd use, you'd stick behind your firewall. And the problem with that is that your machine is only exposed to your experiences. The trick today is to have the machine exposed to not just your experiences, but experiences of all other companies and people like you, right? So to learn across the industry and stop different types of fraud from affecting you that has affected your peer, I think is absolutely useful. The generality, though, is that the fraudulent population is always usually the minority if you're doing your calculations right, and most people are good. The issue is that most good people's identities are now floating in the wild. So the network effect and block lists and stuff only go in so far as helping people who've already been identified as fraudulent not spread in the network. It doesn't stop you from preventing future fraudulent people. And that's the actual problem, right? Everybody wants to increase acceptance for millennials who are thin file. All of this data is out there. You can exploit all of it and establish identities at scale. This is the challenge. As you let more good people in, how do you stop these bad people? Right?
Well, you only use one technology, right? Network effect is part of it, right? So you're
Sure.
going to use other things. But
So, that's actually, you just hit the nail on the head. So it's not really fake identities that are a big problem. It's stolen identities and targeted stolen identities. So, I log on to a Bank of America account or something like that with my identity, somebody having stolen my identity, or getting to it through a remote access Trojan. There's so many different pieces to this problem. It's not just being able to authenticate the fact that this person has created a new identity, and by the way, it doesn't match Facebook or LinkedIn. That's a great signal. Second signal is this person, all of a sudden, their device, if you will, and device, there's a lot of different pieces here. There's device, there's attributes about the people, attributes around social networks, attributes about email, other things like that. But all of a sudden, I see this device that is associated with 50 different email addresses. That's a signal. So there's all of these different signals that have to be processed. And what's happening in the industry, and what will continue to happen in the industry, it just happened to ThreatMetrix, by the way, with the acquisition by LexisNexis of ThreatMetrix, is that we're going to see platforms that deal with all of the different characteristics, and they have to deal with all of the characteristics, all of which are sitting here on this stage, and it has to be integrated into a usable system. And in fact, where we started here on this discussion day, machine learning ends up being very, very useful on that. I mean, when you look at a company like ThreatMetrix, where we're generating 130 million transactions a day, just trying to make sense out of that data in and of itself becomes a very interesting exercise for machine learning. So these things are not really separated silos where I just need to look at LinkedIn data. I need to look at device data. I need to look at network data. I need to look at attributes about that person, whether it's email, address, credit card, ship-tos. What's the history of this person? Do they consistently score well across the network? The network becomes super important. Or do they consistently score badly? Or, I mean, I'll give you an interesting example that we've used for many years at ThreatMetrix. You know, Al Capone can be a internet fraudster Monday through Friday, but he goes to PetSmart on Saturday to get meds for his dogs and has been doing so for 5 years with a valid credit card. I'll inform PetSmart that Al Capone's a fraudster. They don't really care because they're a good customer to PetSmart. So this whole issue of being able to tie together all of this disparate data in real time and be able to scale it, that's really the challenge that everybody's facing. And I think, by the way, the industry's doing a really excellent job of, you know, not just ThreatMetrix, we have lots of valid competitors, of really stitching all of these facts together that deal with global enterprises that really do operate in real time.
So, slight difference of me again. Javelin Research.
I'm glad I have Ray in between the
Exactly.
two of you.
Javelin Research will confirm what I'm about to say, but Javelin Research has shown that actual identity theft and new account opening fraud has actually grown, because when you consider the alternative of account takeover, which is what Reed accurately explained, you know, in account takeover, you're trying to figure out the credentials of the individual, and you've got to navigate the minefield of device fingerprinting and click flow analysis and payment behavior analysis and geolocation and a bunch of checks, right? So there's a bunch of minefields that the fraudster has to navigate their way through, versus they could just steal a bunch of identities and walk through your front door. What is easier? So, you know, naturally, we've actually started seeing a growth in new account opening fraud as opposed to account takeover. I think the account takeover problem and all of these tools and looking at devices and so on are not really going to be required in the next 7 years. I believe that the entire kind of that side of the market is going to contract fundamentally because of multi-factor authentication. So if you consider generally that all of these tools we've built, looking at devices, your IP addresses, et cetera, over the last 15 years, we did that because e-commerce grew on the web, and in e-commerce you have this thing called a guest checkout. Most of us are familiar with it. You don't have to set up an ID. I can go fill my shopping cart with 5 television screens and hit checkout on Best Buy.
You still need email.
Well, you may or may not. Increasingly with mobile apps, you don't need email, you just need a phone number. So my point being that when we look at history and you say, well, you had to go create this, you could just check out completely anonymously, and all you have are the minimal information, maybe a card details of somebody and an address to ship to. That posed a big problem. So we had to come up with ways to identify the individual and use cohort analysis. So we said, well, fingerprinting devices using scripts on websites and stuff is a cool way to do that back in 2009. And what we've seen is that, you know, the notion of commerce has shifted from web to mobile. The generation for the next 40 years that are driving the economy, millennials and Gen Z, are mobile first. It's already been proven. So, you know, the notion that in the mobile space, when any of you install a mobile application, you never have to go in as guest. You always have to authenticate yourself. You enroll. That's the first step to opening up your mobile app. So in that enrollment process, if the person's identity has been digitally verified using a series of tools, and you have absolute assurance that it's that individual, and you've natively fingerprinted the device, which is also a commodity to do today, and then you tokenize that with a biometric, which you can do by drop-loading a free library from Apple or Samsung or Xiaomi, without even having to worry about what you have to do for the biometric. The combination of those three things will establish a very secure token with absolute proof of who you are. And if at any future time when someone's performing an application and they're filling their shopping cart with 5 television screens and they're hitting checkout, I need to know if it's still Sunil or not. I would simply step up the authentication because of the risk level of that transaction, and I would have to prove that I am who I am. The authentication would be handled seamlessly by the device manufacturer. Apple would do Face ID, Samsung might do retinal scan or fingerprints or whatever, and the system will automatically give the application absolute assurance that it is in fact Sunil performing the transaction. So I no longer need 20 other tools to tell me is Sunil posing a risk or not. And we're seeing this right now from the largest e-commerce companies in the world, this shift to mobile, where they're trying to move their retail customers into the digital channel. And if they're doing that, and they're the slowest moving in the entire industry because they're risk averse, you can imagine what the ripple effect in the rest of the market's going to be. So, with that in mind, I don't think half these, your email and phone number, no offense, I mean, we use the same factors, I'm just speaking about the technology. All of these types of checks that we do today in the future are going to be less necessary. The point of ingress, that is the enrollment phase, is the most important part, without which the biometric cannot be trusted. I could steal your Array's ID and have that provisioned into my mobile device and associate his identity and credit card details to my thumbprint. So, to avoid those type of scenarios, you want to make sure the enrollment phase establishes a very strong identity. It can be tokenized by the device, and that's it. That's your future assurance right there.
So now that Sunil has solved that for everyone, we can
There you go.
we
You're
can all
welcome.
pack up and go home. Let's switch in our last few minutes here to talk about some of the challenges we're having with machine learning. Specifically, there have been a number of recent examples in the press and academic literature about unintended social biases being embedded in machine learning algorithms. It'd be interesting for the audience to hear what your companies or what strategies your companies are employing to make sure that there aren't any unintended outcomes from embedded biases.
Should I take that? So
Let's
you want to mix it up, Ray?
Let's give Ray and
Go for it.
and
So ThreatMetrix, first of all, we don't really dictate to our customers what the biases are. Everybody has access to our policy engine. All of these policies are different depending on their risk levels, what they're trying to accomplish. And in many cases, customers care a lot less about fraud, for example, than they care about good customer recognition. So it's really what they're looking for. But it is a very interesting question that you bring up because, for example, if you're dealing with nothing but thin file customers, we have a large customer base, for example, on subprime lending, people like Avant and all of those guys. They have absolute biases that they build in, and it may not be bad that they have biases. I mean, the word bias assumes negative connotation right off the bat, but actually that may be a good thing because really they're managing risk. Where biases end up being very negative for you is if you're turning down good customers, or if you are intentionally letting too many fraudsters through. So it's a balanced issue that you have to look at, and really it just comes down to economics. How much fraud am I willing to support in order to support my business? Because I could take it down to zero fraud, but your business is going to go away with it. So it's not necessarily a bad thing to have biases, and in some cases you want to build those biases in.
You want it to have at least as possible, but that takes time and then training and understanding the models. And we had an example in our company where we have a global company. We have office. We invoice in 40 countries. We thought that the model that will work here will work in the same way everywhere else, right? So we trained the model in a way that, like using an email as an example and understanding the pattern in a certain email, for example, very easy to understand. So what email that has a handle bad boy in the US, it might be a bad thing, as just a high-level example. It might not be a bad thing in Brazil or other places. So we had to solve that bias as we implemented new technologies and new models. We had to make sure that this is not affecting globally. So we take an approach where we face our model based on the industry as well as in a region. So in a way that one thing won't work for everything. Some things will work for everything, but some others don't. Stopping the fraudster is really important for us, but also important is to let the good people pass through. So you don't want your customers to lose the lifetime value of the customer by you stopping them using the wrong algorithm.
Sunil?
So we don't use rules in our system, human-defined rules. A lot of systems that are there in the market, even some emerging platforms from some large bureaus and so on, all still employ rules. And that's a historical thing because human beings like rules. They can understand if A equals B, then do C. The problem with rules is that rules-based approaches in this space are completely reactive because let's say you create a rule that says opening up 10 accounts a day is a sign of fraud. If the fraudster knows that rule, they're going to open up, let's say, 1 account a day for the next 10 days. And now you have to go change your rule. So even with rules induction, what you end up with after a while is a corpus of thousands of rules. And then trying to figure out which rules work and which ones do not, it becomes a nightmare. So you've got this reactive system that's hard to manage. That's part of the problem. The other part is human beings who define the rules use human intuition, and machines can go beyond human intuition to find disparate bits of data and a correlation between them and a causality. We use straight up machine learning. We're like a hardcore machine learning company. That's our blood. We don't use rules. So as a result, when we
do you ever use rules?
No,
never transited to.
No, we do not use rules. So basically, we can create semi-supervised models or fully supervised, unsupervised models. Even in semi-supervised models or unsupervised models, you can do that without actual creation of rules yourself. What you call decision trees. You can create functions that will do the equivalent. When we sell to financial institutions, we are therefore required to pass a higher bar than the rest in the industry. And that's the bar of model governance. Model governance basically is a well-established framework to ensure that your models, given certain inputs, will always have deterministic outputs, to ensure that your models are free from biases, like the redlining problem of racist robots and so on, and to know the degradation curve and the justification for why the model behaves the way it does. And these are very important things to understand how the model behave. Now, if you understand the FICO score, for example, in the FICO score, certain assumptions have been made about economics, which Reid was basically talking about lending and biases not being bad. Well, we've already proven that biases, even though you may have good or bad connotations, negative effects, let's say, of machine learning can have massive consequences in the economy, which is why the FICO score and the credit score specifically prohibit the use of race and gender and other types of variables or features. The machines can start associating randomly, given enough data, to certain signals. For example, it is a known correlation that anyone who eats burnt toast is likely to have a higher rate of cancer. I can tell you, I ate burnt toast this morning. I'm not going to get cancer tomorrow. So there are a lot of factors that can make machines make these predictions. So
hey, Sunil, I want to give Rita an opportunity to respond to, since you.
Go ahead.
Just very quickly. Sometimes you have a super complex system, amazing technology, but it's hard for you to implement, hard for you to.
You have to justify, right?
A question for you would be like, how long you need from data from your customers for them to come on board, for you to start training the machine?
Don't ask him another question. Let's not do it.
To answer Ray's question, sure.
Hey, I want Reid to respond first, and then we can go to that.
Sure.
Okay. So rules are good, actually. So for example, on a new account creation, if all of a sudden I see a person creating an account, but it's being managed through a remote access Trojan, that's a rule. I don't want that person to create an account at that point in time.
Yeah,
so
machines
rules
can take action on outliers too.
Rules are actually a good thing. They are a certain signal, and I agree, by the way.
Yeah.
The problem with rules is that people only add to them, they never take them away, and then the person that wrote them left the company, you don't know what they do. We actually created a product called Smart Rules that goes and fixes that problem for you. It goes and says, which rules should you have, which rules should you not have. So it's not a function that machine learning is a better solution than policies, or that policies are a better solution than device ID or anything else like that. You need all of these pieces to work together in unison. And when it gets complex enough, machine learning ends up being a great way to manage the chaos, if you will. But they're all very valuable pieces.
So thank you so much for your perspectives. I do want to give the audience an opportunity to ask a question or two. Raise your hand, please. Go ahead. And can we get a mic over here? If that's not possible, here.
Well, I'd just like to ask the panel if they've thought about or they are actually doing something about when the bad guys start using machine learning and AI, and how that can they nefariously use that to actually defeat everything you're already doing.
Can I be really quick? So I think the resources on our side, and the merchants and fraud prevention or identity companies side. We have the money we have the data that's normalized on our side. We see the transaction data. We have the resources. We spend more money than we have fraud itself. So you're not going to see a fraudster that's going to spend more money invested in the fraud than what they can get back. But this is a question of a matter of time. I think there are open sources technologies now that anybody can use it, even the fraudster. The point is the data, right? How they can get the data. If they get data from a data breach, all they need to do is mine that data and see what data sets on that data breach they can use that would have more successful. So I think it's a matter of time, but I think today, as I can see, I don't think they're there yet. But that doesn't mean that's not going to.
But
There are fraud rings that. Sorry, go ahead, Reed.
I do think that state-sponsored crime already is employing these
I
kinds of
agree.
capabilities, and you know, again, it's an arms race. It's always been an arms race on these kinds of things, and with ultimately outside of state-sponsored crime, which has political connotations. Ultimately, you just want to make it too expensive for the fraudster to come to your shop and have them go someplace else is ultimately what happens here.
So I disagree with Ray's comment earlier.
Come on, man.
I'm the disagreeable one on the black sheep here. So
You don't get a medal for that, by the way.
Yeah. So it's just different understanding and different facts, right? Like, it is actually possible today to build off-the-shelf AI that can copy any system if the system is not designed properly. All you have to do is point the AI you have against the target system, pass about 100,000 to 200,000 rows of input data into the target system. All you need back are two things, a score and a confidence rating. With that, the AI can learn the distribution of whatever logic exists in the target system, and it can literally do what the target system does without having any clue as to how the target system was built. So if you're building machine learning systems, there are strategies you can use to actually avoid your machine from being duplicated in this manner. And to what I will agree with Rayon is the fact that they're getting smarter. The cost of these tools are dropping on the web, and there are rings today, because at the end of the day, if you can make $100 million or $200 million in fraud outcome, you don't really need state actors to give you the motivation to go commit the fraud.
So
Thanks, Sunil. We're going to go to one more question here.
So, I disagree that I think Sunil's right. That they do have the money, right? They get at least $20 billion a year from cloned devices, cloned cards, and cloned identities. And they don't have the overhead you have because they're using compromised computers, not their own computers. They're working from home. The industry doesn't get to work from home except in isolated cases. They don't pay taxes. You do, except Apple sends it offshore and doesn't pay taxes. But they do have money to compete with you. And until you shrink that number, the financial industry is really the VC for criminals, right? Because they reinvest that stolen stuff into stealing more.
It's a good point, right? Like the entire industry today relies on stolen data for KYC compliance.
So as part of your ML, are you learning these organized rings you're talking about?
Yeah, I mean, sorry, I don't know who the. Go ahead, Ray.
Go ahead. You talk about the rings.
No, I mean, so when we end up figuring out a pattern of fraud, the machine basically uses the notion of collective intelligence to protect other people from that type of fraud. But we do see all sorts of interesting types of attack vectors surface. It just shows you the ingenious thinking and the fact that there's enough technological complexity out there for fraud to be the normal.
So, yeah, in fact, at ThreatMetrix, one of the capabilities that we have through a product called Smart Learning is we can identify threat vectors coming across our customer base typically before individual customers see them, because we see them en masse. And so we do, in fact, update and make recommendations to customers in real time in many cases that this potentially could be a threat. But you're right that effectively what you're talking about is that you have a small subset of the criminal element that is supported by organized crime, or just organized, if you will, and well-financed. And those people are pretty well understood. Citibank will tell you that there's 100 organizations that routinely go after them. Those are the guys they really worry about. So, you're absolutely correct about that. And I think that, for everybody sitting on this stage, the good news is that our futures are very well secured, because you're going to continue to have these escalations of capabilities and financing and so on forth that will require ongoing investment and ongoing purchases of products.
So we're at time, but our panelists will remain afterwards if you want to come up and ask some questions. But first, let's give them a round of applause. Thank you.
Thanks, everybody.